Hello. Today we're going to go to section 7.4, working on adding and subtracting rational expressions. And for our first example, we're going to find each sum or difference. And the first one we'll take a look at is 5 over 21x plus 2 over 21x. Now, notice in this case that we've already got a common denominator. So we can go ahead and add these two fractions together. 5 plus 2 gives us 7 over, our denominator is going to stay the same, 21x. And the last thing we want to do is to simplify if we can. What goes into both our numerator and our denominator in this case? Hopefully you see that both 7 and 21 can be divided by 7. 7 divided by 7 is 1, and 21x divided by 7 is 3x. So our answer is 1 over 3x. For b, we have 4x over x minus 5 minus 3 over x minus 5. Again, we've got a common denominator, so we can go ahead and combine this into one fraction, all over x minus 5. But our numerators are tops. 4x minus 3, those are not like terms. We can't actually combine them. So we just leave it as two separate terms, 4x minus 3 all over x minus 5. And in this case, there's nothing we can do to simplify that. There's nothing that goes into all of the terms. There's no way to factor either the numerator or the denominator. So that is our final answer. If it helps you to have a step-by-step process. Anytime we're finding a sum or difference with rational expressions, the first thing you're going to do is get a common denominator, because they won't all be like example 1 where they already had one. The second thing we're going to do is combine it all into one fraction using either addition or subtraction, whatever is indicated in the problem. And our third step will be to simplify if possible, like we did in 1a. So now let's take a look at what happens when the problem doesn't already have a common denominator, when we have to do a little bit of work to make that happen first. So in example 2, we're going to simplify 5 over 7x minus 3 over 4x squared. Now notice, we don't have a common denominator, although you might recognize that they do have some parts in common. If you have a hard time seeing what they have in common and what we're going to have to multiply to get that common denominator, one strategy that you can use when you have monomials like this is to break them down. So for example, 7x I know is 7 times x. And 4x squared, if I were to break that down, like my prime factorization, if you remember our little factor trees, 4 is the same as 2 times 2, and x squared is the same as x times x. Notice that they both have an x. Okay, so I don't need to multiply by the x that they already have in common. What I need to multiply by to get a common denominator is the things that they don't have in common. So here we have a 7, and here we have 2 times 2 times x. So my first denominator has a 7 that this other denominator does not have. So I'm going to multiply the second fraction by 7. And when you're multiplying a fraction by something, you have to multiply the top and the bottom of the fraction by the same thing. Otherwise, you're changing the value of that fraction. Now our second fraction, our second denominator, had 2 times 2 times x, or that's 4x, that this first fraction didn't have. So that's what we're going to multiply the first fraction by. So now if we go ahead and multiply, 4x times 5 is 20x. And in our denominator, 4x times 7x, 4 times 7 is 28, and x times x is x squared. On our second fraction, 3 times 7 is 21 over 4x squared times 7 is 28x squared. And now we have a common denominator, so we can actually combine this all into one fraction. So now putting this together all over 28x squared, our numerators are tops. 20x, 21, they're not like terms, right? They don't have the same variable. So they're going to stay separate as 20x minus 21. Okay, so I've combined that into one fraction. I want to simplify this if possible, but when I look at this, there's nothing that goes into all three terms. Okay, I can see things that go into like 2 of the terms, but not all 3. And there's no way to factor the top. I mean, well, I guess I could say there's a 1 that goes into them, but there's nothing else that goes into them. So this is as far as we can go. That is our answer, 20x minus 21 all over 28x squared. For our next example, we're going to find the difference I think it's easier just to say simplify. Your book might say find the sum or find the difference, but really it just means to simplify, to do whatever operation the problem says. So we're going to simplify 6 over n minus 3 minus 4 over n minus 5. So this one's a little bit different. We're still subtracting, but notice our denominators are no longer monomials. They're not a single term. In fact, these are binomials, okay? 2 terms that happen to be separated with, in this case, subtraction symbols. There's nothing I can do to factor those denominators. So on a problem like this, to get that common denominator, you actually just multiply by the other denominator. I'm going to multiply the second fraction by n minus 3 on top and bottom. And I'm going to multiply the first fraction by n minus 5 on top and bottom. One of the most common mistakes that people are going to make on these problems is to not distribute. So please watch out for that. Okay? We need to multiply 6 times n and 6 times negative 5. 6 times n is 6n. 6 times negative 5 is negative 30. On a problem that doesn't have monomials in the denominator, we're just going to leave our denominators in factored form. n minus 5, and n minus 3. On our second fraction, if we distribute 4 times n is 4n minus 4 times 3 is 12. Again, leave that denominator in factored form. And now that we have our common denominator, they're both over the n minus 5 and n minus 3, we can combine this into one fraction. Notice the subtraction symbol in the middle. So we're going to be subtracting our like terms. 6n minus 4n is 2n. Negative 30 minus negative 12. Recall that when we subtract a negative, that's like adding. So we really have negative 30 plus 12, which gives us negative 18. So at this point, we have 2n minus 18 over n minus 5 times n minus 3. Recall that our last step, step 3, is to simplify if possible. So hopefully you notice that the top, our numerator in this fraction, can be factored. They both have a factor of 2. So if I pull that 2 out, 2 times n gives me 2n, and 2 times a negative 9 would give me negative 18. So hey, I factored that. Our denominator was already factored. Now, at this point, there isn't a factor that's in both the numerator and the denominator, so we can't cancel anything out. So this would be our final answer, 2 times n minus 9 over n minus 5 times n minus 3. Now, if you're just doing the work for me, I don't mind if you leave your answer like this when nothing's going to cancel out. But if you're doing your work on big ideas online, they're going to expect your answer looks like this. So watch out for that. We have 2 more examples to go today. So example 4, we're going to simplify. (5x) over x squared plus 9x minus 22 plus x minus 4 over x plus 11. If you look at this first fraction, that denominator x squared plus 9x minus 22. Hopefully you'll recognize that that is something that can be factored. And that is the very first thing that we want to do here. Always factor your denominators if you can. So the pair of numbers that multiplies to give negative 22 and adds to give positive 9 is positive 11 and negative 2. So our factors are x plus 11 and x minus 2. Our second fraction, that denominator can't be factored, so we're going to leave it alone for right now. X minus 4 over x plus 11. And now we want to get that common denominator. Notice that both of these fractions have a factor of x plus 11. But our first fraction has a factor of x minus 2 that the second one doesn't have. So that's what we need to multiply by to get that common denominator. So my first fraction is going to stay the same. 5x over x plus 11 times x minus 2. My second fraction, again, we can leave that denominator in factor form. Now when I want to multiply out the x minus 2 times the x minus 4, okay, you can either use your double distribute, okay, or you could use a box to help you multiply that out. If I'm multiplying x minus 4 times x minus 2, x times x is x squared. X times negative 2 is negative 2x. Negative 4 times x is negative 4x. And negative 4 times negative 2 is positive 8. So in my numerator, when I multiply that out, we got an x squared. Negative 2x and negative 4x combined to give us negative 6x. And we have a positive 8. And now that we have our common denominator, we can go ahead and combine this into one fraction. This time we're adding. We're going to add all of our like terms together. So I have no x squareds in my first fraction, plus 1x squared in my second fraction gives me an x squared. We have 5x in our first fraction, plus negative 6x. So 5x plus negative 6 gives me negative 1x, or you could just write that as negative x. And I have no constant term here, plus a positive 8 gives us a positive 8. All right, so we've combined this into one fraction. Now we just want to check to see if we can simplify this. So looking to see if I can factor the top there, is there a pair of numbers that multiplies to give positive 8 and adds to give negative 1? Well, let's see. The things that multiply to give 8 are 1 and 8, or negative 1 and negative 8. Well, those don't add up to negative 1. The other numbers that can multiply to 8 are 2 and 4, or negative 2 and negative 4. Those also don't add up to negative 1, so it looks like this cannot be factored, so it's already simplified. This is our answer. All right, I'm going to turn my paper over for our very last example. So for example 5, we're going to simplify x minus 7 over x squared plus 9x plus 20 minus 9 over x squared minus 25. Pardon me. So we want to start by factoring our denominators if we can. So the pair of numbers that multiplies to give positive 20 and adds to give positive 9 is going to be 4 and 5. Now, if you were stuck, you couldn't figure out what that pair of numbers was, you can always make yourself an organized list. Okay? The smallest number that goes into 20 is 1. So 1 times 20 is 20. Well, that doesn't add up to 9. Now, you could also do negative 1 and negative 20. But again, that's not going to add up to 9. The next smallest number that goes into 20 is 2. 2 times 10 is 20. Or you could do negative 2 and negative 10. But neither of those pairs is going to add up to 9. So if I keep going, 3 does not go into 20, but 4 does. 4 times 5 is 20. So is negative 4 times negative 5. And hey, this is the pair that adds up to give me positive 9. So again, our factors for our first denominator are x plus 4 and x plus 5. We also need to factor our second denominator in this one, x squared minus 25. Here, we're looking for a pair of numbers that multiplies to give negative 25 and adds to give nothing, right? There is no x term there. If it helps you, you could put a little plus 0x to remind you. So a pair of numbers that multiplies to give negative 25 and adds to give 0. Hopefully you come up with positive 5 and negative 5. So now that we have it factored, we can figure out what we need to multiply by to get that common denominator. Notice they already have an x plus 5 in common. So we just need to multiply by the things they don't have in common. Our first fraction has an x plus 4 in the denominator. So we need to multiply the second fraction by x plus 4. Our second fraction has a factor of x minus 5 in the denominator that this one did not have. So that's what we need to multiply our first fraction by. All right, so when I go to multiply my first fraction here, I've got a binomial times a binomial. So again, you might find it helpful to use a box to multiply that out. So I want to multiply x minus 5 times x minus 7. X times x is x squared. X times negative 7 is negative 7x. Negative 5 times x is negative 5x. Negative 5 times negative 7 is positive 35. So for our first fraction, we have x squared. Negative 7x minus 5x is going to give us negative 12x and our positive 35. Over in our denominator, we have an x minus 5, an x plus 4, and an x plus 5. Minus all right, if we multiply out our second fraction, well, this one's nicer because it's just a monomial times a binomial, so we can just distribute. 9 times x is 9x. 9 times 4 is 36. And now we can combine this all into one fraction. So our denominator, we have the x minus 5, our x plus 4, our x plus 5. All right, so looking at our numerators, I have an x squared in my first fraction minus no x squared. Okay, so x squared. Negative 12x minus 9x is going to go more negative. Negative 12 minus 9 gives us negative 21x. And then for our constant term, 35 minus 36 is negative 1. And the last thing we want to do is look to see if this can be simplified. Is there a pair of numbers that multiplies to give negative 1 and adds to give negative 21? No. So this is already simplified. This is our answer. X squared minus 21x minus 1 over x minus 5 times x plus 4 times x plus 5. Your assignment is on page 388 in your textbook and is numbers 19 through 24. For those of you that are going to email me a picture of your work, make sure that you have actual work and not just the answers if you want to receive credit. If you need help, please reach out via email or contact me during my office hours. Good luck